All right, I'm picking up where it left off a second ago. So we're here. I added a 3 coefficient to the sodium hydroxide. So that's going to make this a 3, this a 3, and this a 3. And now we are equal across the whole thing. So 3 sodium hydroxide plus the FeCl3 yields 3 sodium chloride plus iron hydroxide. Okay? All right, next. Sorry you're having to watch a couple videos. For whatever reason, it cut me off, and I don't want to have to re-record. Okay. Next one is CaBr or Ca2Br2 plus NaCO3 yields CaCO3 plus NaBr. Okay, good. So let's draw our chart. We have Ca, Br, Na, C, and O. Let's write it over here. Ca, Br, Na, C, and O. Okay, there's 2 calciums over here, 2 bromines, 1 sodium, 1 carbon, 3 oxygens. Let's go over here. We have 1 calcium, 1 bromine, 1 sodium, 1 and 3. So you see the only 2 we don't have matching are the Cas and the Brs. Well, unfortunately, they're in different compounds on this side of the equation. So we need to figure out both sides. So, okay, let's go ahead and start with the Ca. So I'm going to put a 2 there, and this is now going to become 2. But it's going to make our carbon also 2, and now it's going to make our oxygen 6. That seems like a slight problem, but bear with me. Okay, I'm also going to put a 2 in front of NaBr because over here bromine has 2. 2. And now I'm going to, and that also means that Na is 2. So there's our new numbers. Let's come over here and see if we can fix it. So this one's good, this one's good. These 2 need fixing, or these 3 need fixing. So that's NaCO, and those are all in the same compound. So hopefully we can just put a 2 here, and that makes that 6, 2, 2. Yay, we're done. Okay, so 2, or it's 1, 2, 2, 1. I'm sorry, 1, 2, 2, 2. You don't need to put a 1 here, it's assumed. But when you have this, the coefficients here, those are going to be stated. All right, let's do the next one. All right, the next one is H2 plus Cl2 yields HCl. So draw a line. We have H and we have Cl. We have H and we have Cl. This one's easier as far as the numbers go. 2 and 2, and over here we have 1 and 1. So we just throw a 2 up there, and we're done. That was easy peasy. Okay, last one. From your homework is CdCO3 yields CdO plus CO2. So we have CD, we have C, and we have O. Over here we have CD, we have C, and we have O. Okay, we have 1 CD here, we have 1 C, and we have 3 O. We have 1, 1, and then for O we have 1, 2, 3. they are already equal, so this is balanced, so you don't change anything. Okay? All right, that's your homework. Let's go ahead and do our section 5 notes. Section 5 is about chemical reactions. So I'm going to erase this. Your question for today, your question is, what happens to chemical bonds during energy exchanges? And your heading is chemical reactions. By the way, reaction is abbreviated like that. And then we're going to talk about types, rates, and energy. Oh, good. It still fits. All right, I'm going to switch colors for fun. All right, so the first type of reaction, so this is your heading. Your first type of reaction is a synthesis reaction. Synthesis means to make, to synthesize, think to make, to build, to put together when you synthesize something. So this is a reaction where two or more substances combine to form another substance. So it would look like A plus B yields AB. So we put them together. A plus B yields AB. Okay, my video cut off, and so I'm just going to talk you through this one. Decomposition reaction. That's where something decomposes or breaks apart. Think when you think of something that decomposes back into the earth. Same idea. This is a decomposition reaction of a chemical. And so that means that it is starting as something and breaking into its simpler parts. So a reaction where one substance breaks down or decomposes into two or more simpler substances. Okay. Now, the next one is let's see if I have some room. Single displacement reaction. I am not liking the color of that marker, so let's switch. Okay, we'll try this one. So a single displacement reaction is a reaction in which one element replaces another in a compound and so it looks like this. So we have A plus BC yields AC plus B. Or A plus BC yields AB plus C. Okay, either of those are examples of a single displacement. A is replacing the B here, and over here, A is replacing the C. Okay, it's called single displacement. It's one element, single, displace, or like change out, displace another element. So that's single displacement. All right, lastly, well, not last type, not last part of the notes, but last type is, pause it if you didn't finish writing. Is a double displacement reaction. A double displacement reaction is a reaction that results in what's called a precipitate. Think precipitation is when water condenses from a gas into a liquid, and it's either in the form of rain or snow, but there's precipitation. A precipitate is a chemical coming out of solution into from going from liquid to solid form. So it results in a precipitate, water or gas, when a positive ion of one compound swaps with another positive ion of another compound. So, don't mind my dogs. So we have AB plus CD, okay? We have AB plus CD. This will yield a switch, so AC plus BD. Okay, so see how we switched here, okay? And we switched, well, we didn't, it was more the B in this. Here, let me fix that. We swapped out the B and the C. Okay? It's double displacement because the B goes this way and the C goes this way. It's two pieces moving, two ions moving. All right, so moving on from the types. So you had 4 types. You had synthesis, you had decomposition, you had single displacement, and double displacement. Now we're going to talk about energy. So, chemical reactions involve energy exchange. And we're going to see this in 2 ways. We're going to see exothermic, and we're going to see endothermic reactions. Okay, so this is exothermic reaction, endothermic reaction. All right, exothermic is a reaction in which energy is released in the form of heat. Okay, and examples of this would be burning wood, or fireworks exploding. Okay, going here. Endothermic reactions are reactions in which heat energy is absorbed. Examples of this would be those chemical ice packs, or also photosynthesis. So exothermic means heat is released. Endothermic means heat is absorbed, or energy. We're talking heat is a form of energy. Okay, now we have two more words to define. We have the word catalyst. You may have heard of this word just using it in the English language, but it's used in science to talk about speeding up a chemical reaction without itself being permanently changed. So a catalyst is something that's going to kind of push the reaction forward. A lot of times, think of it like if you have a ball and you're wanting the ball to roll down the hill, but there's like a slight uphill. A catalyst is just kind of pushing it up the uphill to get it to go down the hill by itself. So I'm not really changing anything permanently, but I'm giving it a little extra boost. A catalyst is that extra boost, okay? And then the last word is inhibitor. An inhibitor, it prevents or slows a chemical reaction or interferes with the catalyst. Okay, if a reaction, you don't want the reaction to occur, you can introduce an inhibitor that slows it down or prevents it from taking place. It can interfere specifically with the catalyst, or it can just slow down the whole process altogether. Okay, those are your notes for today. Thanks for joining in. I will have office hours. Please check those out if you're needing extra help. Bye.